Okay, now we're going to take a look at this question right here, and it's kind of a bigger question, but it's this is kind of the format that you might see on an exam where we're asking you for the properties of the graph of a function. What we do is we provide you with the derivatives so that you're not spending your time fighting with those guys right there. So let's take a little bit of a look here. So here's our function, f of x is equal to x over the natural log of negative x over 2. And we're going to analyze the function with respect to the following. So first of all, we're going to take a look at the limit of f of x as x approaches 0 from the left. Okay, so I'm going to do each of these kind of one at a time. Now I'll start with, we'll do an a over here, because I think I might be at a loss for space here in a bit. So first of all, we're going to take the limit as x approaches 0 of this guy right here. So it's the limit as x approaches 0 from the left of x over the natural log of negative x over 2. Okay, now probably the easiest way for us to kind of think this one through here, because I've got this linear function divided by a logarithmic function here, let's just take a look at what they're doing separately. First of all, as I approach 0 from the left of x, that's just going to approach 0. Okay, well that's not really causing me all that much stress here. Let's talk about what happens when I approach x from the 0 of the natural log of x, negative x over 2. Now, I'm going to go over here. My natural log, if you remember what a natural log looks like, okay, it's going to be the natural log of x. The graph is going to look something like this. Okay? Now, if I put a 1/2 over that, x over 2, that's going to horizontally stretch that by a factor of 2, which is going to spread that out a little bit here. So it's going to go like this. Okay, so instead of going through 1, it's going to go through 2 here. And a negative in front of that, inside the argument there, is going to cause a reflection over the y-axis. And so it's actually going to do something like this. It's going to flip out like this. So what's happening here for this graph, and this is the graph of the natural log of negative x over 2, as I approach 0 from the left, okay, this graph is dropping towards negative infinity. So what's happening here, if you will, is I've got this numerator going to 0 and I've got the denominator going to negative infinity. Now, that means that my answer here would technically be like a negative. Actually, sorry, that's not true. That's not true. Sorry, the negative over the negative would cancel. So this is going to be like 0 from the negative side going down to negative infinity. So the negatives would cancel here. But think about what's going on here. As the numerator gets smaller, the fraction gets smaller. As the denominator gets larger, the fraction gets smaller. Now when I say larger, I mean in terms of value here, not in direction. So what I've got here is a 0 on top of an infinity on the bottom. This is going to 0. Okay? This is most definitely approaching 0. I know it's a little bit harder to think it through like that, and it requires a lot of familiarity or comfort level with the graph of the natural log, but that's probably the quickest way to go about getting that answer. Okay, let's take a look at the next piece here. We're going to find the critical numbers, points of inflection, and cusps. So what we're doing here is we are taking a look at the first and second derivative here. Okay, to find the points of inflection, sorry, not the points of inflection, I want the critical numbers first. I go to my derivative and my first derivative and my second derivative. I'm going to find out where they're undefined or equal to 0. However, I got to go back to my original function because before I can make those judgments, I need to know what the domain of this function is. Now, because of this denominator right here, the numerator has no issues. It's all reals. But the denominator here, that natural log, okay, that natural log means that I've got a limited domain here. Normally, the domain of a natural logarithm would be greater than 0. But in this case, because of the reflection, it's actually going to be less than 0. Okay? So my domain would be x is less than 0. And except for one other little thing here. If the natural logarithm, if the whole thing becomes 0, then I'm dividing by a 0, and that's not acceptable. So I got to figure out where that thing becomes 0. So let's go down over here. The natural log of negative x over 2 equal to 0. Can't let that happen. Convert that to the exponential. E to the 0 is 1 equals negative x over 2. So if x is equal to negative 2, the natural logarithm goes to 0, so I can't let that happen. So not only does x have to be less than 0, but I can't allow x to be equal to negative 2. So I got to let those kind of influence my decisions as I take a look for critical numbers and points of inflection. I apologize for that beeping in the background. Out of my control. So here, let's take a look at the first derivative. I am looking at where this thing could be undefined first of all. Now, this would be undefined at negative 2, but that's not in the domain of the function, so that does not come across as a critical number. Okay? So my critical numbers have to be where the numerator goes to 0, where the whole derivative goes to 0. So that's going to be the natural log of negative x over 2 minus 1 equals 0. Okay, let's solve that. Bring the 1 over. Convert to the exponential, so that's going to be negative x over 2 is equal to e. E to the 1 is equal to that. And then so x is going to equal negative 2e. Okay, so right there, there's a critical number. Now, I'm going to look for points of inflection. And I'll just kind of fit this into the side here. Points of inflection. I know that's pretty tight there, but okay, either way. Look at my second derivative. My second derivative is going to be undefined when x is equal to negative 2, but again, that's not in the domain of the function, so I don't even worry about it. So I'm going to look at where it goes to 0, where the numerator goes to 0. So 2 minus the natural log of negative x over 2 equals 0, and I know that's tight. Bring the natural log over. 2 is equal to the natural log of negative x over 2. Convert to the exponential. E squared is equal to negative x over 2. And so I'm going to get this negative 2e squared. Oh, sorry, you can't. I'm so sorry. You couldn't see any of that. That's all this work right here. Sorry, I set the second derivative equal to the numerator equal to 0. Bring the natural logarithm over. Convert to the exponential form, the base is e. And then divide by the negative, bring up the 2. So x equal to negative 2e squared is a possible point of inflection. Or it could be a cusp, don't know yet. Okay, I have to investigate the intervals of concavity before I'll know for sure. But I'm going to use those numbers to do that. Okay, next thing I'm going to look at here are intervals of increase and decrease. So I'll put that C down here. And we're going to take a look at that. That's where I'm looking at the first derivative. Okay, now I'm going to look at the number line here. I've already used the first derivative to find a couple things. I already know that my domain is going to be like from 0 back, but not including 0. And I know that there's an issue back here at negative 2e. Okay? Now, I'm going to pick a number between negative 2e and 0. Let's pick negative 1. We're going to choose negative 1 here. I'm going to use that to test to test the first derivative here. If you plug in a value here at negative 1. What do I got here? Negative 1. Oh, sorry. And my mistake here. I'm forgetting there's one other thing here. There was an asymptote there at negative 2. Sorry. I got to be a little bit more specific than that. So I've got negative 2e here, and I've got negative 2 there. I forgot. There was that asymptote that was in there. Okay, forgot that there was an undefined. It's just kind of was sitting right over there. That's why I noticed it there. So, okay, between negative 2 and 0, I'm going to pick a number like negative 1 and plug it in here. That will make my denominator positive. The natural log of that'll end up being 1 over 2 is going to be a negative squared. Okay, so the whole thing's going to become positive. If I plug in the negative 1 into that changes this into a negative here. Sorry, the natural log will be a negative because this becomes a positive fraction. And I know that sounds kind of weird, but if you look at the graph, that's how that works. If you take the natural log of a number that's between 0 and 1, the result will be negative. And if you subtract 1, you get a negative. So in that little interval right there, this is going to be decreasing. If you choose a number between negative 2 and negative 2e, and let's actually choose negative e, for example. If I plug the negative e into that, makes it positive e over 2. When you take the log of that, that's going to be just a positive value. Square is going to be positive. Here, if you put negative e into that, the negatives will cancel. okay, e over 2, okay, well half of e, when you take the natural log of that number, that's going to give you a fraction between 0 and 1. Okay, because the natural log of e would be 1, so the natural log of half of e is going to be a smaller number, and when you subtract 1 from it, you will get a negative. Now you can plug that into your calculator to check, but you're going to get a negative there. And if you throw in a number that's less than negative 2e, I don't know, let's throw in like negative 10 or whatever, well, first of all, the denominator is going to be positive because of that. And if you throw in like the negative 10 into this, the negatives will cancel. 10 over 2 is 5. When you take the log of that, that will be larger than 1. So that whole numerator is going to become positive. So that's going to make this positive right here. So I'm going to have an increasing interval here from negative infinity up to negative 2e. And I include that negative 2e, okay, because I want to be clear that that's not an asymptote. I'm including that, okay. That's a critical number. It's going to be decreasing from negative 2e to negative 2, and I put a parenthesis around that because that is an asymptote. I'm not including that. And then union negative 2 up to 0. And again, I'm not including the negative 2 because it's an asymptote, and I'm not including the 0 because 0 is not in the domain of the function. Okay, that's right up there. That's the what you might call the supremum of the domain there. Okay, so there's my intervals of increasing and decreasing. All right. D, intervals of concavity. Okay, let's do that maybe just over here. Okay, D. Intervals of concavity, again, I'm looking at that number line there. Here's 0. Not looking at anything beyond 0. Negative 2 is still important because it's an asymptote. And then over here we discovered that negative 2e squared, that was an important number for this as well. That was a possible point of inflection. Could have been a cusp, don't know yet. Don't know until you investigate this a little further. So now we're going to choose a number between negative 2 and 0, and we're going to plug that into our second derivative. Let's say like negative 1. So if I plug negative 1 into this is going to become positive 1/2. The natural log of positive 1/2 will be a negative. Cubed will be a negative. So the denominator is going to be negative there. If you plug negative 1 into this, the natural log of positive 1/2 is going to be a negative. Okay. And then that's the log will be negative. Oh, now I got to think about this whole second. I'm going to plug that into my calculator. I'm going to double check that. So if I plug in, let's plug negative 1 into that. 2 minus the natural log, and all of a sudden I'm having a bit of a brain fart on that, minus negative 1 divided by 2, and then divided by the natural log, 1 divided by 2 cubed, and I am getting a negative. All right. So that means that we're expecting a negative in there. Okay, now I'm going to dive back in here. I just took a brief little break here because there is an error here, and it hasn't really affected us at this point here, but it is going to affect us now because this is incorrect. Okay, sorry, I walked us through that there, but that's incorrect. Now I'm going to show you why here. When this was typed out here, there was a small typo. There should have been an x down in the denominator there in the second derivative. Now, normally it would be an appropriate thing to ask, does that affect our points here? And the answer is no, it didn't actually in this case, because the possible point of inflection that it introduced was a 0, and 0 is not in the domain of this function, okay? We've already kind of gone through that. The domain has got to be, here it is, less than 0, so 0 is not included. So the absence of that x there actually, at this point, up to this point, didn't cause any problems, but now it's going to cause an issue, because that, if we're picking a number between negative 2 and 0, that is actually going to cause that to become positive. It's going to change the sign there. Okay, and that's what that should be. It should have been positive in between negative 2 and 0. If we choose a number between negative 2 e squared and negative 2. For example, like negative e, okay, and we go back up to here. If you plug negative e in, now that's going to be negative e, so there's a negative. If you plug negative e into here, you're going to get positive e over 2. And cubed, you're going to get a positive number there, but that negative in front is going to make the whole denominator negative. If you plug the negative e into here, you're going to get log of e over 2. That's going to be a fraction, less than 1. So 2 minus that is going to become a positive value over that negative, means this part here is going to become negative. And if you choose a number that's less than negative 2e squared, so it's going to be like, let's say like negative, I don't know, like let's like negative 100, that becomes negative. This becomes positive. Cubed is still positive, so this whole thing becomes negative in the denominator because of that. If you plug in negative 100 into here, this becomes positive, but 2 minus that really big positive number, okay, is going to be a negative. And so negative divided by that negative over here in this section way out here is going to be positive. So the concavity, therefore, this is going to be concave up, okay, from negative infinity to negative 2e squared. I include that with square brackets because it is a point of inflection. It's a spot where these two intervals overlap. So that's going to be part of both of those intervals. So union, and then out here, and I use parentheses on negative 2 and 0 because those two endpoints aren't included there. This will be concave down on negative 2e squared up to, but not including negative 2. Okay, sorry about that. I know it didn't seem like a big amount of time there, but it took me a few minutes in between to figure out what was going on there. Okay, so now that was D. Now we're going to find the exact coordinates of any maximum or minimum points. Okay, well that's just going back and using the information that we've got right here, and I suspect after E it's going to be inflection points, and yeah it is. So here we go. Here's E. I already can tell you right now that because this negative 2e is the endpoint of an increasing sequence and the beginning point of a decreasing sequence, that this is going to be a max, and it's going to be negative 2e. Now let's get the coordinates. So if we plug negative 2e into this, let's think about that. It's going to be negative 2e in the numerator, negative 2e, negatives cancel, 2's cancel, natural log of e is 1. So the answer is going to be negative 2e. The y coordinate's negative 2e. That's kind of convenient. Okay, so there's our max. Go to our point of inflection, because that's what it is, because the concavity is in fact changing at negative 2e squared. Okay, let's go back and change that. So negative 2e squared, plug that in. So if you plug that in, negatives cancel, 2's cancel, but the natural log of e squared is going to be 2. And so those will cancel, so we're going to end up with negative e squared. So our point of inflection in exact values will be negative 2e squared, negative e squared. All right, now we're going to graph the function. This is g. The last thing we're going to do, g. So draw out my coordinate plane there. And here, actually I'll zoom back a little bit. What I like to do with this, first of all I'm going to put an open circle there because I'm going to approach the origin. It doesn't exist over here. And what I like to do with this is I'm going to draw a number line up top, and I'm going to identify the intervals of increasing and decreasing here. So I know that there's an issue here at negative 2. Okay, so at negative 2 here, remember that was the asymptote. And then over here at negative 2e, okay, that was a spot where the increasing and decreasing changed. So it was increasing to the left of that, decreasing, and then decreasing again. Now underneath this, I'm going to draw another number line, but down here I'm going to identify where concavity changes. Okay, and again, 0 is a dead end. Okay, and with concavity, again we had negative 2, it changed there, and then we had over here a little bit further. So we'll come a little bit further over here. We've got this negative 2e squared. So it was concave up here, down here, up here. So now let's work our way. Oh, sorry, and then we should identify the points. Okay, I got to remember to identify the points here. So negative 2e was going to be like right here. Negative 2e squared, negative e squared was going to be a little bit lower than that, actually. Not a heck of a lot, but a little bit lower. So now let's work our way backwards here, because I got an anchor point right here. I know the graph's going to approach this. In this interval, I'm concave up and decreasing, and I've got an asymptote here. And I'm approaching this point from the left. So this has got to look like this. Okay, there's really nothing else that I can do to draw that any differently. Now here, in this interval right here, it's decreasing, it's concave down, it's approaching an asymptote, and I know this is a maximum, so I mean this has got to look like that. In this little interval right here, from this point to this point, it's still concave down, but it's increasing. So from here, I'm going up to a maximum, so it's got to look like this. Then, from this point on forever backwards here, it's still increasing, so it's got to be going up, forever going up, but it's concave up. So this has got to be kind of swooping down like this. But this is never going to curve around back up. It's just going to keep going down, it's still going to be slightly curved, concave up. So there you go, and that's what that function is going to look like. Sorry about the mistake with the x in the denominator, but it was not a bad conversation for us to have.